Welcome to all the students, and in this lesson we'll continue with paper 1 of November 2023. This time question 5 and 6. Let's get started. So question 5, normally also a function question. So the graphs are minus a half, x minus 1 squared plus 8, and gx, which is d over x, which means it's a hyperbola, are drawn below. A point of intersection of f and g is at B, the turning point. That's very important to note, that they have the turning point in common. Okay, so the graph F has an x-intercept at -3 and 0 and at 5, 0, which is also indicated on the graph itself, and a y-intercept at point C. Right. Let's quickly have a go at the first question. Write down the coordinates of the turning point of F. Now, very important, if they already give it to us in the format of a -1/2 x minus 1 squared plus 8, this is the turning point format. We can just say it is at 1 and 8. And remember, look at the sketch. The x value should be the axis of symmetry for the parabola. So if I look at 1, that makes sense as it's exactly in the middle between the two x-intercepts. So if they didn't give it to us, we should have known it would at least be at x equal to 1. Right, next question. Calculate the coordinates of C. We know C is the y-intercept. So let's quickly do that. So 5.2 means that y is equal to -1/2 0 minus 1 squared plus 8. So it's -1/2 plus 8, which would just give me 7.5, or 15 over 2, meaning C is at 0 and 15 over 2. And that's the answer. Now they're asking me for the value of D, meaning if we go back to the question, we actually need to determine this equation. Now, very important, D or A or anything that we need to calculate which is exactly in that place that indicates the shape, we can only calculate that with another coordinate. Fortunately, we know B is at 1, 8. So let's quickly substitute back and we can start. So if gx is equal to d over x, we can say that 8 is equal to d over 1. So d will be equal to 8. And that's the answer. Let's just quickly go back to the graph itself then. Am I comfortable with a positive value for d? And yes, I am, because the hyperbola is in quadrant 1 and 3, the positive quadrants. So I don't know if the 8 is 100% correct, but I do know the positive answer is what I was looking for. So, last question now for this first 4. Write down the range of G, meaning the range of the hyperbola. So I know if the equation is gx is equal to 8 over x, I know I have two asymptotes. The one would be at y equal to 0, x equal to 0. What does that mean? There's a limitation on your domain and range. So just for a range, I will say y can be any value except y cannot be 0. Let's have a look at the next few questions then. For which values of x will fx times gx be smaller or equal to 0? So this is a typical question that we can expect. So first things first, quickly put in the coordinates, the 1 and 8. We know that's 7.5, and that's about it. So when I approach these types of questions, I would prefer to use a bit of color. So I will say fx times gx is smaller and equal to 0, meaning it has to give me a negative value with the product. So if f is positive, g must be negative, and if f is negative, g must be positive. So now I'll typically use color. So for g, I will use purple. So gx, which is the hyperbola, that would be indicated with purple. And then for fx, I'll keep to the green, just to clearly distinguish. So if I have a look, where is fx positive? And it's from -3 to 5. It's all at the top of the line. Now look, where is gx negative? It's this whole section here. Now look at the x values. Is there somewhere where these two are overlapping with values? And you will see it's this section here. So from 0 and to -3, or -3 to 0 at least. So that definitely would be part of the solution. So I would say x has to lie between 0 and -3. But hold on, they said smaller and equal to 0. Now the first question is, can x be equal to -3? Yes, there are valid values at both graphs. So it can be larger and equal to -3. Whereas 0, I can't accept it, because remember, if you look carefully, there are actually asymptotes for the hyperbola, and we can't use 0 as a solution. So that is the final answer. Now we look at the next question. Calculate the values for k so that hx is equal to -2x plus k will not intersect the graph of g. So what can we do? Look carefully. So I'm going to start off. So if they were to intersect, it means gx should be equal to, and it's equal to, I just need to quickly get the graph name, it was hx. So I'm going to put it equal to each other. I'm going to say -2x plus k should then be equal to 8 over x. Let's quickly try and simplify, multiply out with the x. So 8 is equal to -2x squared plus kx. So 2x squared minus kx plus 8 will be equal to 0. So now I've got an equation, but I can't solve k because I don't have x. So what can I do? I won't be able to tell them what would be the exact values of x that I'm looking at, but I do know I can use nature of roots to determine k. So for it to not intersect, it means it has to be non-real. So your discriminant must be smaller than 0. So b squared minus 4ac must be smaller than 0. So go back to your equation. A is equal to 2, b is equal to k, and c is equal to 8. So let's have a go. So b squared minus 4ac is k squared minus 4 times a times c, smaller than 0. So I will get k squared minus 64 smaller than 0. So once again, it's k minus 8, k plus 8 smaller than 0. Factorize it. Please remember critical values, otherwise you'll lose a lot of marks. Would be k equal to 8 or k equal to -8. Draw a small parabola for me when we answer this. So it's -8 and 8. So if it's smaller, then it would lie in between. So this means my final answer would simply be k lies between 8 and -8. And that is the answer. It only has to be smaller than 4 non-real roots. Now let's quickly go back in the last one. They say H is a tangent to G at R, a point on the first quadrant. Calculate T such that fx plus t will intersect g at r. Okay, so it's a tangent to g. So I maybe first need to get the contact point, because then we'll have the gradient, which is equal to -2. So that would be the first thing that I would have to calculate. So let's quickly just make a bit of room. Please make sure that you did make all the notes necessary. So I will just do that, take that away. Right, let's quickly have a go at this. So I'm just blocking this off so that we clearly distinguish. So the last question, the 5.7, let's quickly get started here at the top. So remember, I know the gradient is -2, and the gradient will be equal to the first derivative of g. So let's quickly get the first derivative. First derivative of g will be equal to, but remember, gx is equal to 8x to the -1. Remember, we need to rewrite it. So then it would be -8x -2, so -8 over x squared. But we know it will be equal to -2. And now I just need to solve for x. So once again, I would start changing it around, and we would get that x squared is equal to 4. So x could be equal, hold on, x squared, I'm just quickly checking here. Hold on, I made a slight error, just bear with me real quick. I just need to quickly do this real quick. So remember, we are going to use the gradient principle. Just take one step back, because they said hx is -2x plus k, and it will not intersect the graph of g. Now they say it has a tangent at g at point r, at a point in the first quadrant. Calculate t so that it intersects at r. Very important, we're looking at a first quadrant value. So let's go back. First quadrant value, yes, put it equal to the -2. And we'll get -8 over x squared. You'll get x squared is equal to 4. So x is equal to -2 or x is equal to 2. Because they specifically said first quadrant, it means the -2 is not applicable. So I'm at x equal to 2. Now, very important, this coordinate specifically lies on g. We need to get the y value for the contact point. So I will simply go then. So that would be my first step. This would be my second step. I want to get the y value at g. So I'll simply say g at the point of 2 is simply 8 over 2, which is 4. But now I need to figure out, for example, it should be here more or less. How many units do I need to move this parabola down to get to this coordinate? So I'm going to get the y value of the parabola as well. So if in the point 2, if you substitute it in, you will get a value of 15 over 2, or 7.5. So if you look carefully here, this would be at 7.5, this would be at 4. So how many units do you need to move down? 3.5 units. So therefore, t will be equal to -3.5, as it needs to move the whole parabola down with 3.5 units. Let's go for question 6. So Patrick deposited an amount of 18,500 Rand into an account earning R% interest per annum, compounded monthly. After 6 months, his balance was 19,319 Rand 48 cents. Calculate the value of R. So once again, no monthly installments, no fixed amount at a specific time. There's no X. So it's not an annuity. It is just normal 8-pin equations. So 6.1.1. And we can simply say A is equal to P 1 plus I to the power of N. So your A value would be 19,319,48 is equal to 18,500 1 plus R over 12 times 100. So that's the interest rate to the power of 6, because it's only for 6 months. Alternatively, you could have said a half times 12, half a year for the 6 months, times 12 for the monthly compounded. Okay, now we just need to solve for R. So you'll simply get the 1 plus R over 1,200 to the power of 6 is equal to 1,04429. So how do I solve it then? You just take it to the power of 1 over 6. To the power of 1 over 6. So I will just get that R over 1,200 after I took over, let's rather do it like this, 1 plus that would give us 1,00725, and it continues on. Take the 1 over, and I'll get R over 1,200 is simply equal to 0,00725. Continue on. Multiply out with 1,200, and R would simply be equal to 8.7%. And that's the answer. Next question, the effective interest rate. So please remember, effective interest rate, you must know the formula. So we can say 1 plus I effective over 100 is equal to 1 plus the 8.7 over 100 times 12, it's still monthly compounded, to the power of 12. Very important for me is that we remember that effective interest rate and nominal interest rate are compared over the period of 1 year. So please remember, even if they refer to 5 years investment or 2 years or 6 months in this case, we only compare it on a 1 year basis. And now I need to solve for I effective. And you would simply get that your I effective is equal to 9.06%, always a bit higher than your nominal interest rate. And that's it for the first part. Let's look at the next part. So for 6.2, Kuda bought a laptop for 10,000 Rand on the 31st of January 2019. He will replace it with a new one in 5 years' time, on the 31st of January 2024. The value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. Straight line method, guys, that's referring to your simple interest. Right, simple interest, straight line method. After how many years will the laptop have a value of 0? So let's quickly get started and use the data. So we know A is equal to P 1 minus I, because remember we're depreciating N. Let's quickly substitute everything in. 0 equals 10,000. 1 minus 0,2 or 20 over 100 N. Now I need to solve. Divide both sides with the 10,000. N's out of the way. So it means 0 is equal to 1 minus 0,2 N. So 0,2 N is equal to 1. Therefore, n will be equal to 5. After 5 years, the laptop will be worth 0 rand. So why is this important? It means when he wants to purchase a new laptop, he can't use the old laptop for a deposit or sell it to use the money as a deposit. So he won't have a deposit at all. Because if we look at the second part now, Kuda wants to buy a laptop that costs 20,000. So unfortunately, the old laptop won't have enough money or a value so that we can have a bit of a deposit. So that 20,000 rand, he needs to get it from scratch. In order to cover the cost price, he will make his first monthly deposit into a savings account on 28 February 2019. So literally the month after his first purchase. He will make his 60th monthly deposit on 31 January 2024. The savings account has an interest of 8.7% per annum, compounded monthly. Calculate his monthly deposit. So that constant deposit, that's referring to the X. So now we need to decide, is it a future or a present calculation? And we just say, when will he have the large sum of money? That 20,000, will he have it now or only in 5 years or 20 years' time? Only at the end of the 5 years, meaning it's an F formula. So let's quickly have a go. So F is equal to X 1 plus I to the power of N. Sorry, the bracket goes there. And remember, always make sure you understand the difference between the F and P formulas. And if you're struggling, go back to the previous work where we did discuss it further in the lessons itself. All of it over I. So let's substitute in. I know this would be 20,000 rand. X, I need to calculate X. I'll have 1 plus 8.7 over 1,200, meaning the 12 times 100, to the power of 60, because we made 60 payments. All of it over 8.7 over 1,200. Now we just need to simplify and solve for X. So I would literally use my calculator and calculate this whole section, and then just take 25,000 and divide it with your answer. And you should get a value of X equal to 267 rand 26 cents. So now he needs to make every month a payment so that after 5 years he has enough money to purchase the 20,000 rand laptop. Let's quickly have a look at the last question. Tino wins the jackpot of 1.6 million. He invests all of his winnings in a fund that earns an interest of 11.2% per annum, monthly compounded. He withdraws 20,000 rand from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000 rand will he be able to make? So, again, we know now the X is equal to 20,000 rand. We have the interest rate. We're looking for the N. The question, however, is simply then, what equation? Will we use an F or P? He's investing it, and normally investments are F. But when will he have the large sum money? Does he have the large sum now or in the future? And the answer is he has it now. So that means it's a P equation. So let's get started. So P is equal to X 1 plus I to the power of N minus 1 over I. Start substituting it in. 20,000 rand is equal, not 21.6 million. Remember, that's the total amount he got. 20,000, that is your X value. Start substituting in. So it's 1, quickly just bear with me, I wrote the F formula, not the P. This part, remember, it has to be 1 minus 1 plus I to the power of negative n. So just correct that quickly, please. Always keep the formula sheet close by, as it can make a huge difference. Right, so it's 1 minus 1 plus 0,112. So it's already the 11,2 divided by 100 over 12 to the power of negative n, as we need to solve it, over the 0,112 over 12. Now we need to simplify in a way to get the n exponent on its own. So let's quickly start and see how far we can take it. So I will get, if I try and simplify, meaning multiply out with the denominator, divide by the 20,000, we'll end with 1 minus 1 plus 0,112 over 12 to the power of negative n equal to 56 over 75. So as these are quite important and sensitive to rounding off, you just need to remember, keep it maybe in a fraction until the very end to get the most accurate answer. So once again, we get 1 plus the 0,112 over 12 to the power of negative n equal to 19 over 75. So here, you'll definitely need to use a log. We won't be able to get the same base. So I'll simply go and say negative n is equal to log. Remember, this is now the base of the exponent. It will be the base of the log as well. 1 plus the 0,112 over 12, 19 over 75. So you literally type it in, and you'll get negative n is equal to negative 147,80, meaning n is equal to 147,80. What does that mean? This means months. But for how many of them could he actually withdraw the full 20,000 rand? Only for 147. So only 147 full withdrawals. Of 20,000 rand. Very, very important. What happened with the commas 8? What's happening there? That won't be a full 20,000 rand. And that is it for this lesson. I'll definitely see you in the next one.